We're going to continue on with our test review sheet number 1 for our Unit 6 probability, question number 14. You have to take a true-false quiz, and since you have been absent from class, you have not been able to study. If the test has 3 questions and you randomly guess the answer for all of them, what is the probability that you will get all 3 of them correct? Show your work and answer as a fraction, decimal, and a percent. Let's go back and take a look at the important things. The questions are true-false questions, class. So how many possible answers are there? That's right, there are 2 possible answers. That means there are 2 outcomes. A number of things make me happy, not sure yet, but I know that every question has 2 outcomes. If the test has 3 questions, so there's going to be 3 events. You could say 3 trials as well, but 3 events. And you randomly guess the answer for all of them. What's the probability you get all 3 of them correct? Well, let's just take a look at, remember class, I taught you, when you have multiple events, just treat every event individually. I got 1 true-false question. How many things will make me happy if I guess that question? Well, only 1 of the answers is right. How many possible outcomes are there? There's 2. So if I guess it correct, it's 1 out of 2. And the next question is really not influenced by the first question. They are independent events. That means for the second question, I would also have a 1 out of 2 chance. 1 thing makes me happy out of 2 possible things. And the third one, the same thing. 1 out of 2. And we've learned about compound probabilities, or multiple events that we want to all happen. You multiply. Multiple events, multiply. Multiple, that's right, multiple events. If I can actually write this correctly. Multiple events multiply. So we're going to multiply that together and we get 1 over 8. Remember, you multiply the numerator, 1 times 1 times 1. Denominator, 2 times 2 times 2 is 8. Our fraction is going to be 1 over 8. That decimal is 0.125. And our percent is 12.5%. All right, number 15. You buy 4 tickets for a raffle, and there are 20 other tickets in the raffle for a total of 24. So I can write down right now, I already know class, there are the number of outcomes equal 24. Okay, on the first pick, you are not selected. So the first pick, you don't win. If the ticket picked is not put back, now we have dependent events, not put back in the bin or the bag, or whatever they're picking from. What's the probability you will win on the second pick? Well, on the first pick class, we had a possible 4 things would have made me happy over a total number of 24 things. And now, one of the other tickets was picked. So that means we still have 4 tickets in the bin or bag. But now there are only 23 tickets available. So that means our fraction, the probability that we'll win on the second pick, is actually 4 things make me happy over now a total of 23 things. And that is 0.174. Don't forget to round that correctly. I believe that's 0.173, and the next number is 5 or greater, so it goes to 0.174, or 17.4%. All right, let's begin to tackle the tree diagram. Number 16. You and your friend win an award for never being tardy to class. For the prize, you both get to pick from a bag containing 3 blue tickets, 2 white tickets, and 1 green ticket. A blue ticket will win a $10 gift card, a white one will win a pass to Magic Mountain, and a green ticket will win an iPod mini. You will each get to pick 1 ticket from the bag without returning it. All right. So, take a look at our total outcomes first. Letter A is how many tickets are in the drawing? Let's take a look. We got 3 blue, 2 white, and 1 green. 3, 4, 5, 6. How many trials will there be? You will each get to pick 1 ticket, and 2 of you are working, you and your friend. That means one of you is going to pick 1 time, the other one's going to pick 1 time, so there'll be 2 trials. Are these independent or dependent events? We've already figured that out, class. If you're taking a ticket from the bag, the first, whichever one of you picks a ticket first, you're not putting it back. That means the probability of the second trial or event is changing. So these are dependent events, and you can decide on your own how to describe that. How do you know they're dependent? Based on what we just saw in the question. Make a tree diagram that shows all the possible outcomes of the drawing. Be sure to write probabilities of each branch as well as the final probability of each possible outcome. We've done this in class a number of times now. What are we tracking, class? Now I know there's you and your friend, but notice the tickets don't belong to us. I don't have blue and my friend has white. So all we have is the colors of the tickets in the bag. So in this case we are tracking colors. So we've got blue tickets, we've got white tickets, and green tickets. Alright, what's the probability, the first ticket, whether it's me or my friend, doesn't matter who, what's the probability of picking a blue ticket? Well, there are 3 blue tickets in the bag, and there are 6 total tickets. White tickets, there are 2 total tickets out of 6 tickets. And green, there's 1 green ticket out of 6 tickets. Okay, got our first probability. Our next branch, we're going to go with blue, white, and green again. Blue, white, and green. And if we pick a green, we still can pick blue, white, and green. Alright, first thing I want to point out is we can already know this. If 1 ticket already got picked, that means in our next level, the denominator is going to be 5. Because now there's 5 tickets available. So I'm just going to put a 5 there right now. I'll be done with it. Has to be over 5. Every one of them has to be over 5. And over 5. Oops, I put a 1. Don't know that yet. But we do know that when 1 ticket gets pulled out and not put back, now our number of outcomes or total tickets in the drawing change. Alright, if a blue gets picked first, how many blue tickets are left? 2. If a blue gets picked, how many white tickets are left? We still have 2. And how many green tickets are left? We still have 1. Next level, if a white gets picked, how many blues are left? We still got 3. How many white tickets are left? Well, 1 was picked. That means there's 1 left. How many green tickets left? We still have 1 green ticket. And then if a green was picked first, of course we still have 3 blue tickets left. We've now got 2 white tickets left. And the green was already picked. There are no green tickets left. Let's multiply our probabilities. 3/6 times 2/5 is 6 over 30. 3/6 times 2/5, again, 6 over 30. 3/6 times 1/5 is 3 over 30. 2/6 and 3/5 is 6 over 30. 2/6 and 1/5 is 2 over 30. 2/6 and 1/5 is also 2 over 30. 1/6 and 3/5 is now 3 over 30. 1/6 and 2/5 is 2 over 30. And 1/6 times 0/5 is 0 over 30. Not going to happen because there's not 2 green tickets. Okay, I've taught you guys circle. Oops, that's a bad circle. Circle these because these are the ones you're going to be using for all of your answers after this. Every probability of every branch. And remember also, class, since a tree diagram lists every possible outcome, these better add up to 30 over 30. Let's check it. 6, 12, 15, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. That means our total probabilities are 30 over 30. Boom, it adds up to 1. That means our tree diagram appears to be accurate. Let's find our 2 answers now. Letter E. You both want to pick a white ticket so you can go to Magic Mountain together. What's the probability that this will happen? Show your work. Well, if we're going to both pick a white ticket, the only branch that counts is white, white. Nope, 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 nope. There it is, white, white. 2 over 30. In fact, in this case, class, it's asking me to show my work. Okay, fine, I'll show my work. 2 over 30 equals 2 over 30. Not much more I can show than that. My fraction is 2 out of 30. That means my probability is pretty small, 0.067 or 6.7%. Probably not going to happen. That's very low probability. Take a look at letter F. So the chances are we're not both going to go to Magic Mountain together, but it could happen. Still could happen. Letter F, what's the probability that one of you will win the iPod Mini? Show your work. Well, I got to find out which ticket wins an iPod Mini. Oh, the green ticket wins an iPod Mini. So if either one of us pick a green ticket, we're good to go. Let's find out how many branches give us green. Nope, nope. There's our first one, blue and green. So that's 3 over 30 that one of us wins. Notice, class, we don't even know who picks first. Doesn't matter. As long as one of us wins, we're going to be happy. White, blue, white, 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 green. There's a good one too. 2 30ths. 2 over 30. And then, oh, all these branches look like they're good. 3 over 30, because the first pick is green. And then 2 over 30. And of course, this one is not going to happen, but let's just write it so we can show our teacher we understand how a tree diagram works. Let's go ahead and remember, class, on a tree diagram, once you do all the multiplication, there's no more multiplication to do. Everything else at this point is adding the branches that make us happy. So in this case, we just add them up. And we end up with 3, 4, 5, 6, 7, 8, 9, 10. 10 over 30. So our probability of one of us winning the iPod Mini is 10 possibilities. 10 things make us happy over 30. Put that in your calculator. That's 0.333 or 33.3%. We'll stop this video and we will tackle the Venn diagram on the last video.